Okay, so now we are going to import this data into pandas. So we will start the Python interpreter and we will import pandas. So we've seen this before when we covered the reading data lecture. And now we will read in this. Sometimes it takes a little while to import this module. And now we will read in this data. So again, we use the read CSV. The index column equals 0, so we're specifying that first column of data we want to use as the index, and we can also specify the separator, for example, if we want to. So this is successfully imported. Everything looks pretty much fine. You could have also specified the first column to be the index. And so you'll notice that this has changed a little bit. So the gene name is now the first column, and then that is the other column. So the changing this just changes what we use as the index, so which column of data we use as the index. So for this lecture, we are just going to use that first one, but you're kind of free whenever you import data to choose what it is. So we have created what is called a data frame object, and this is one of the most important things to know, is that this data frame object is kind of the primary way that Pandas stores this data. So, it's kind of like a dictionary or a list. It's just an object that stores data that has all sorts of methods that are attached to it that are very useful. So, if we want to see what is in here, we can just type DT, but there's so much data that you can't actually print all of it to screen. So there's 13,669 rows and 130 columns. So, you can't show all of that data when you print it out. And so you see they have these little ... dots. And so this just means the first column is gene name, worm base ID. So that shows you the first 4 columns. And then it skips the rest, and then it shows you the last 4 columns. And then same with rows, it shows us the first 5 rows, skips a bunch, and then it shows us the last 5. So in general, you don't really want to look at data. You just kind of want to make sure that everything looks right. But you can also use things like head. And so this is a method that allows you to control how much data you see. So if you just wanted to see the first one, if you wanted to force it to print the first 20, that's one of the things that you can do. And then tail is kind of the opposite of that. If you want to show the last 20 rows, then you can do it that way. So there are 13,669 rows and 130 columns in the data frame. And so now when you access it, it's important to note that there's 2 fundamental ways that you access data, and the data is what's called indexed. And so one of the indexes is the column. So it's it's stored, it's a flat data structure, it's a column and a row, but each column has a specific name. So this data is special. The way this worm base ID is stored is separate from all of the data within this column. And then similar with the rows. So the rows has what's called an index. And so each row has this special index that you use to access it, and then everything else is like just kind of data within the table. So, think about it as column heads, and then indexes are the primary ways that you organize this information. So every single cell, and a cell is a single unit of the table, every single cell has a unique address. You would start with the column name, and then you would give it the index, and so then you would know exactly where it is. So in Microsoft Excel, when you open something, you can, if you're used to using Microsoft Excel and formulas, the way you access this is using this up top. So A, B, C, D, E, F, G, and then this on the left is the index. So, if I wanted to say, create a little formula on Excel, I would do something like this. So dx2. So the way my address for the cell is that the dx is the column, and then the 2 is the index, and then I could add that to dz, 2 if I wanted to, and then I have a little formula. So in pandas, these column names and these indexes play that same role. So if you want to see, what the columns are in your object, then you can just use, so this is stored as an attribute called DT columns. And this is a different type of object called an index. So this is an index object, so it's kind of like a list, but it's not exactly like a list. If you wanted to, you could turn it into a list, just by sending it into the list constructor. And then if you wanted to get to the index data, so that is the index attribute, and again, this is its own unique data structure that acts a lot like a list. So it also has information about the data type. So in this case, we're storing the column names as an object data type, and then for the index, we're storing it as an integer 64. And then it also includes information about the length of the index. So as you see, there are 130 unique columns and 13,669 unique rows. So let's say we want to filter this. So let's say we want to access just a small portion of the data. So one of the ways we could do that is by using the column names and the row names to filter down to specific parts. And then again, just like the way you do that for a list, you use what's called a slicing operator. So DT, and then if we provide it with the name of the column, then it restricts it just to that single column. So now we've returned only the data that is within the column along with the index of it. So it's really two columns. The first column is the index, and then the second column is the data within the column that we want. And we could do that for any one of these. So if we wanted to access the data for VC, if we wanted to access the data for ADA, those are all reasonable options. So the way we did that is that we used the slicing operator, and then we sent it a string, which is the name of the column that we wanted. We can't do that with the row. So if we tried to send it the row index, we get this error, and we get this key error because this only works for columns. And so what this is saying, this key error is saying, is that there's no column named 1. So if you misspell something, you're going to get a key error, and that just indicates, oh, I tried to access like a column that doesn't exist. You can also access data for multiple columns, and that is by sending it in a list of strings. So now within the slicing operator, I sent it to a list of length 2. The first element is ADA, and the second element is ADE. And so now I get it for both, and I can do that for as much, and I'm going to have to follow the syntax, and I can do that for as many columns as I want. So if I want to filter this down to specific columns, one way to do that is provide the name of every single column that I want. Maybe you want to remove specific columns. So, let's say I have my data table, and I don't want to include the names of the genes anymore. I just want the part of the table that lists the actual expression data. So how can I get that? So based upon what we've already learned, one of the ways you could do that is create a, there's a lot of creative ways you can really do this stuff, but one of the ways you could do this is just list out every single one of these columns. But I would have to write out 128 column names in order to do that. So that might be a pain. So you might, in order to do this, what you might want to use is this this method called drop. And so what drop does is it allows you to drop out specific columns. So if we wanted to remove gene name, then we simply do this, and now we notice the table that returns no longer has that gene name column. And then again, we could also provide it with a list if we wanted to remove multiple columns. So if we also wanted to remove worm base ID, then we could do something like that. Let's see. You could also use list comprehensions if you wanted to. So x for x in dt dot columns if worm base if x not in worm base ID or gene name. Ah, shoot. So you notice we've returned a data column, and this doesn't have the two gene names, worm base ID or gene name. So why did that work? Well, we created this monster list that has all of the column names except for worm base ID and gene name. So that'd be another way. In general, there's lots of ways to accomplish this stuff. So right now, just kind of do whatever works, and then eventually you'll move to methods that you like the best. All right, so we've covered how we can access data of specific columns. Now, what if we want to access specific rows? So now we have to use this. I think it's called an attribute. But it's kind of like a mixture of a slicing operator and a method. So, and I guess it's called an indexer object, but I've also seen it called an attribute. So normally, if you had a method, you would use the parentheses in order to use it, but you actually use the slicing brackets if you want to use this indexer. And so the way this works is that you simply send it a list of the rows that you want. So you have to use a list of rows. So if I want 1, 2, and 3, then I simply provide it with that. And then lo and behold, I have, instead of having this 13,669, I just have the 3 rows. And so you're actually using whatever value is within this. So for this index, this is an integer object, and so that's what I'm using. So it's not that I'm saying it to send like the 1, 2, and 3rd row. I'm saying send the rows that actually have this this stored right here. So for example, you can't use 0 because so you might be used to things that are like indexed with 0, but you can't use that because none of these index names are 0. You also can't send it a single row like this. That does not work. So you would get an error if you tried to do this. So this is just different from columns. So with the columns, you can send it a single key and it's able to find it. With this, you're not able to send it a single index. You have to send it a list. And so the list can be of length 1. So if you only want the first one, then you just simply do it like that. But again, actually, sorry, maybe that does work. That is interesting. Sometimes it does work and sometimes it doesn't work. Yeah, so maybe it does work. Maybe that part of that is actually incorrect. So now we have a way to access the rows. Now we can also combine these if we want to access a subset of rows and columns. So this returns all of the columns, and then we can take that and then use our brackets to restrict it to whatever columns we want. And ADA, ADE, ADF. Sorry. And I have to send it as a list. Otherwise, it doesn't work. And so now I've been able to return this 6 this data frame. So what's returned is a data frame object that has 6 cells within it. What if I want the value of a single cell? Then in that case, you would do something like this. And so I've used the LOC attribute. I've sent it the name of the attribute, the name of the index that I want, and then the name of the column that I want. And so now what is returned is an actual number. So this is a numpy float, which is just a type of float object that's a little bit more accurate than your normal float that Python uses. But if you do something like this, where you, instead of sending it a single index, you send it a list of indexes, or if you do something like this, where you send it the data that you want, and you can do it that way. So it's just important to note that if you only send it a single row back, then you can access the individual data. Otherwise, what gets returned is actually a data frame object, and so you're not actually able to access the individual data that way. So what do I mean by this? So in this case, the type of the object that is returned is a series object. And so if I try to do something like this and I try to add 2, it doesn't know how to do it. So if you need access to the individual number, you just need to make sure that the way you're accessing it returns a float or an integer or a string or whatever it is.